All right, so 7-3, day 2, we're going to finish up this lesson today. We're just going to be doing hypothesis testing with rejection regions again. This time it's a t-test instead of a z-test, though. You're going to see it's really, really similar. The t test statistic formula that we need, we've used this in the past when we were doing confidence intervals. Only difference between this and what we use for z is it's now an S for sample standard deviation rather than our lowercase sigma that represented the population standard deviation. All of these other conditions are the same that we're looking for at the start of our problem. We want either the sample needs to be random, and then either my sample size bigger than 30 or the population normally distributed. So you guys have on your paper the steps that we're going to use for the hypothesis testing. So we're going to do this one together. All right, so it says a used car dealer says the mean price of used cars sold in the last 12 months is at least $21,000. You suspect this claim is incorrect and find that a random sample of 14 used cars sold in the last 12 months has a mean of 19,189 with a standard deviation of 2950. Is there enough evidence to reject the dealer's claim at a level of significance of 0.05? Assume the population is normally distributed. Okay, so checking my things to start here. Do I have a random sample? Yes. Right there. Okay, is my population normally distributed or my sample size at least 30? Normally distributed. Okay, so we're good on our initial conditions here. Let's go ahead and write our hypotheses, the null and the alternative. The dealer is claiming that the mean price of used cars sold in the last 12 months is at least $21,000. So at least would be what inequality symbol are we going to use? No. It's going to be the null, and then greater than or less than. At least greater than or equal to 21,000. Now it does say you think this is false, and we've seen that in problems before where as a researcher, if you think something's false, you make the claim then the other hypothesis, the alternative hypothesis. The reason that we're not going to do that in this problem is at the very end, we're saying we want to reject the dealer's claim. Remember, if you want to be able to reject something at the end, you make the null hypothesis your claim. If you want to support something at the end, you make the alternative hypothesis your claim. So that kind of affirms, if you're not sure where it's supposed to go, that little word there is enough. What's my alternative hypothesis going to be? The mean is less than, and from that, you should be able to tell me, is it left tail, right tail, or two-tail test? This is a left tail test because that alternative is less than. Okay, other things that I know, I'm going to go ahead and label them here. My sample size n is 14. The sample mean is 19,189. And my standard deviation came from that sample, so it's an S. And that's my big clue that I'm going to be using t-tests and t-distributions here rather than my z's, which is 2950. I also had that level of significance of 0.05, so I'll just label that. Okay, you should be able to, on your t-distribution, we know it's going to be a left tail test. From what we've labeled so far, you should be able to find that critical value of z, or t, excuse me. Got it. All right, this is what we practiced yesterday. If it's a left tail test, remember it's going to be negative. Okay, so on your t distribution is where we're looking. We are going to look at a one-tail test, so that's the second row across the top. Go over to our level of significance, which is 0.05, so that'll put me in the second column. And then we also need to know our degrees of freedom. What's the degrees of freedom for this one? 13, you could always label it if you needed to. It's always one less than our n. So if I go in that second column down to 13, I'm going to get 1.771. And then we talked about yesterday, if it's on the left side, you put a negative in front of it like so. It's on the left side of the curve. If it's on the right side, it's a positive. And if it's two-tail, you just put a plus or minus because you're going to have one on each side. Okay, so that is the shaded region, the rejection region. So what we're going to do now is calculate our own t, our own test statistic, and figure out, is it going to be in that rejection region or not? So again, the formula is x bar minus mu divided by standard deviation over the square root of n. X bar, 19,189. Mu is 21,000. S, 2950 over the square root of n, square root of 14. And I did this earlier, and I'm going to give it 3 decimal places because that's what my critical value is. Negative 2.297 is our test statistic. So now we need to make our decision. Is our test statistic, our t-value, in the rejection region, in the shaded area? Yes, it is less than the negative 1.771. So if we're in the rejection region, what decision do we make? Reject. What are we rejecting? Which hypothesis? The null hypothesis is always what we are rejecting or not rejecting. Okay. Then we summarize. We say there either is or is not. Which one? Is enough evidence to reject or support. Reject, remember that's what we wanted to do from the start. The car dealer's claim that the mean price is at least $21,000. This is what I want you to do on the test when it says summarize in context. You're going to write that little sentence that we practiced, and then pretty much at the end, you're just restating the claim, what you have either chosen to reject or not reject, support or reject, okay? Any questions there? All right, so because this is so similar to the z-testing, I don't think we need to do 2 more of these. We'll just do 1. So why don't you guys work on this one on your own? And then I'll give you a few minutes to put the answers up on the board. We'll check it, and that's really all you need to know for the rest of 7-3. Okay, here's what I got. Make sure when you're looking up that critical value of t, you're using at the top where it says two-tail test, and then when you're going down to your degrees of freedom, plus or minus in front of that number. Also, just a reminder, if your degrees of freedom isn't on there, you always round down. Okay, so if you had like, I don't know, 68 isn't on there, you would use 60 for your line, for your critical value, okay? What questions do we have? All right, so 7-3 Math Excel is a 1-part Math Excel. It is due tomorrow night. You guys have time now to work on that. Tomorrow we're going to do a short lesson. 7-4 is our last lesson, and then we'll start getting ready for your last test and your final. Getting close. Okay.